In today's lesson, we're going to work on evaluating expressions. Our goal is to write and evaluate an algebraic expression for a given situation using substitution. In this lesson, you will learn how to evaluate a multiple-step algebraic expression by substituting numbers for variables. So let's review. In previous tutorials, you've learned how to apply order of operations to evaluating expressions, and now of course we're going to take it a step further. Equations. We remember order of operations. We remembered as PEMDAS, and it consists of 4 steps: parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. We also review that an algebraic expression consists of numbers, variables, and operations. You can represent multiplication and division with expressions in multiple ways. For example, 3x plus y minus 4. That is represented with numbers, variables, and an order of operations. Some common mistakes are forgetting to use the correct order of operations. We remember again PEMDAS, and there are a few mistakes that people make when completing the order of operations. Sometimes they go out of order, but one of the most common is multiplication and division. Some students don't use them interchangeably from left to right. Sometimes students will do all the multiplication, then division, and take PEMDAS too literally. Same with addition and subtraction. And also another common mistake is thinking that the only variable to use is x. For example, you can use any variable. 3 times q is minus 4 is perfectly fine. And technically, your variable can be any symbol, but we usually just represent it with letters in this context. But it really can be anything. So let's get started. If we have an equation, 14x plus the quantity 6 minus x, 4, x equals 4. How do we find the value of a multiple-step algebraic expression? Well, we have to remember to plug in the variable if we're using substitution. So instead of the x, everywhere I see an x, I'm now going to put a 4. Now, 14x literally means 14 times x. And we don't have to put times x or a dot to represent multiplication or even parentheses. But once we put that number in, then we do. So in this case, I'm going to use parentheses for multiplication. And I can add 6 minus 4. So that's my first step. First step is to rewrite the expression with my substitution. Then I need to follow the correct order of operations. Parentheses first. Now looking at this one, we know that this is not the type of parentheses where we're following order of operation. This is a multiplication problem. So this is a common mistake you want to also avoid. So parentheses first in this case is 6 minus 4. 6 minus 4 is 2. So I'm going to rewrite everything the same. We have 14 times 4 plus 6 minus 4, 2. Notice how I wrote multiplication another way because I'm trying to represent different ways. Then I can keep going through my checklist. Exponents. I don't have any, so I can skip that. Then I have multiplication and division from left to right. Well, all I have is multiplication, 14 times 4. Using the distributive property, I can do this in my head. 4 times 4 is 16. 10 times 4 is 40. 16 plus 40 is 56. And I have 56 plus 2. And again, addition and subtraction from left to right is 58. So I know that 14 times 4 plus the quantity 6 minus 4 is 58 when x equals 4. So that's a substitution expression. Let's try a few more. Evaluate 5/10 x minus 4 when x is equal to 8. Again, whenever we see it right next to each other, it's what kind of a problem? Multiplication. So I have 1.5 times 8. And I've represented it with a dot. I always avoid, when it's algebra, using the multiplication sign x, because then people can get it confused with an actual variable. So we have 5/10 times 8 minus 4. Multiplication comes first because in my order of operations I don't have parentheses or exponents. So multiplication and division, I have multiplication. 5/10 times 8, well, 5 times 8 is 40. Move the decimal once, that gives us 4. You can also look at it as half of 8. 4 minus 4 is 0. So when x equals 8, 5/10 x minus 4 is 0. Make sure you're pausing to make sure you have all these steps in your notes. Moving on again. What if you have more than one variable? Well, it's just important that you keep track. In this case, I'm going to color coordinate mine. So I have y is 5/10. So I'm going to rewrite the expression with my numbers instead of my variables. So that gives me 1 squared plus 10 times 5/10 for y. So now I have everything I need to follow my order of operations. I don't have parentheses. I do have exponents. Common mistake, students will multiply 1 times 2, but 1 to the second power is 1 times 1, which is 1. I keep my addition sign the same because next step, of course, is multiplication. I don't have division. 5/10, well, times 10, my decimal rule that I remember, hopefully, from previous tutorials. I can move the decimal once to the right because it's multiplication by 10. So that gives me 1 plus 5, and then, of course, addition, no subtraction, is 6. So when we have two different variables, we just need to make sure we're plugging them in the correct order. Evaluate 3xy for x equals 2 and y equals 5. So we have x and y. So what does that mean? A common mistake is students will write 325. No, don't do it! This is a multiplication problem because it means 3 times x, which is 2, because we plug it in where we see it, times y, which is 5. Then I can multiply from left to right. 3 times 2 is 6. 6 times 5 is 30. Circling my answer to make sure it's clear. So again, in your keys, you might want to point out common mistakes to avoid. We've done quite a few examples so far. Let's keep going. Again, another one that connects with order of operations. So we're going to plug in 9 for n and 3 for m. So I'm going to rewrite the expression. Always rewrite the expression. 9 minus 3 divided by 4. And remember from previous tutorials, order of operations, there's imaginary parentheses here. So don't forget that. So 9 minus 3 is 6, and 6 divided by 4 can be reduced. There's one group of 4 in 6, so that would be 1, remainder 2/4, or 1 1/2. So again, we have to connect this to order of operations. Notice how I've written PEMDAS on every single page to help remind you. I recommend you do the same. Now let's look at this problem. We have 3q plus 6 times the quantity s minus 5. So first we're going to rewrite using our numbers instead of variables. So we have 3 times 7 plus 6 times 10 minus 5. So now I've rewritten my problem, and now I, of course, follow my order of operations. I have parentheses first. And again, don't confuse this parentheses with this parentheses. Here's my parentheses. So I'm going to keep everything the same. 3 times 7 plus 6 times 10 minus 5 is 5. So then I'm going to do exponents next, which I don't have. Then I'm going to do multiplication and division from left to right. Well, I don't have division, but I can multiply. So that gives me 3 times 7, which is 21, and 6 times 5, which is 30. Then, of course, I use addition and subtraction from left to right. 20 plus 30 is 51. And now I've completed all of my steps carefully. Now you can also use the distributive property to solve this expression, but in this case it was much easier to use your parentheses first. Let's look at a word problem. The total earnings of a person who earns D for dollars for W weeks is given by the expression dollars per week, dollars times the week. For Layla's summer job, she earns $120 per week for 9 weeks. So she earns $120 per week for 9 weeks. Evaluate her earnings. So how much money will little Layla make if she has this job? Let's check it out. So first we're going to rewrite the problem, dollars times the week. Well, she earns 120 for the D. And then we know that 9 is our weeks. So I have 120 times 9. And in this case, I actually will use the distributive property because I can do it faster if I make this 100 plus 20 times 9. And then I can distribute that. So, of course, 100 times 9 is 900, and 9 times 20 is 180. 900 plus 180 is $1,080. So Layla would make $1,080. I've modeled using the distributive property. You can go back to other tutorials to get extra help in that. But if you just multiplied up and down 20 times 9, you would have had the same answer. Now it's your turn to try these problems. So you're going to evaluate each algebraic expression. For every x you see, you are going to plug in a 3. And for every y that you see, you're going to plug in a 15. So make sure that you are paying attention to what I've pointed out, the common mistakes, to avoid them. And remember what it means when numbers are next to each other, how we write them when we have variables next to the 12, for example. So remember to take special note of what these symbols mean, and remember to follow your order of operations. Go ahead and take a minute to pause the tutorial and try these problems on your own. In this lesson, you've learned how to evaluate a multiple-step algebraic expression by substituting numbers for variables. In following tutorials, you're going to need to solve what those variables mean when you don't always have a number to plug in. But in this case, you were plugging in numbers using substitution. I hope that you are understanding all of these steps, and if you need any help or assistance, make sure you're going back to other tutorials to review order of operations or distributive property. In addition, your teacher is always here to help you at any time that you have questions or need help. Come ready to discuss your guided practice as a number talk. Great job today, and great job with your introduction to algebra.